This presentation is specifically for hotel MEP consultants because HVAC is calculated precisely. Electrical systems are sized conservatively. Fire protection is never underestimated. But when it comes to STP, we suddenly become optimistic. Today, we're not discussing about hydraulics. We're going to discuss about COD because when COD is underestimated, biology does not cooperate. Most hotel STPs are designed assuming COD of less than 700 milligrams per liter. A stable organic load is assumed. Uniform sewage pattern is also assumed. Let me ask you honestly, when you designed your last hotel with a banquet, did you calculate COD based on the kitchen scale? Did you reuse a residential assumption? You might have developed a spreadsheet and asked a vendor to fulfill it. Let's just assume an apartment or a household kitchen. A few residents live. There's controlled cooking in a predictable pattern. Whereas in a hotel kitchen, so much is cooked in a very short period of time. Continuous cooking activity happens. There's a bulk dishwashing that's happening. Oil-heavy gravies are prepared, and most of them are dumped into the sewers. And we still assume domestic COD. This is not intelligent bioengineering. This is biological wishful thinking. In a hotel with just in-house guests, COD is less than 2000 milligrams per liter from the restaurant. There may be a buffer already 2 to 3 times more than that of a domestic kitchen. The contributing factor can be a buffet cooking, bulk dishwashing, and especially in Indian kitchens, there's a heavy oil load. Now, let me ask you something as engineers. If electrical load increases 3 times, would you ignore it? Would you say the transformer will adjust? No. Then, why do you expect biology to adjust? Organic load is also load. It just happens to be invisible. That doesn't mean that you ignore it. Let's take the case of hotel with restaurants and bars visited by people other than in-house guests. Here, the COD is about 4000 milligrams per liter. This is not a minor variation. That's a completely different biological mass that is coming into the wastewater. But what changes in design? Probably flow rate, or not even that. We still treat STP like plumbing, but STP is not plumbing. I told you already, it is bioengineering. In recent times, we've been asked to give designs to hotels with banquets, and some of them even have multiple banquets. Now, here comes the real blind spot, the banquet hall. Let's assume a hotel with 120 rooms, but there may be guests that are exceeding 800 numbers on a day of a wedding. Hydraulically manageable, biologically really an explosive. On such event days, CODs can touch up to 10,000 milligrams per liter. What we have designed for is for 500 milligrams per liter, now operating at 8,000 milligrams per liter. If HVAC load increases 15 times, no consultant would approve it, but because it's sewage, we say, operator will manage. Microbes don't attend coordination meetings. They respond to loads that is coming in the sewage treatment plant. I think you got the message. Now, let's get some clarity. Domestic sewage has COD less than 700 milligrams per liter. A hotel with in-house guests, probably up to 2000 milligrams per liter from the kitchen. Hotel with bar and restaurants can go up to 4000 milligrams per liter, specifically from kitchens. Banquets, special days where banquet is occupied, the COD can shoot up to 10,000 milligrams per liter due to heavy cooking happening. Now, Think as a process engineer. If COD increases by 5 to 10 times, oxygen requirement increases, reactor stress increases, biomass stability reduces. But in design, the tank size remains the same. Blower capacity is almost the same. Design philosophy has never changed. That's where the problem starts. As engineers, let's get something very clear. STP is not plumbing. It's a biochemical reactor and a biochemical system that does not respond to optimism and wishful thinking. They respond to load rates. If COD doubles, oxygen demand doubles too. If COD increases 10 times, stress level increases 10 times. Biology is not intentional. It is also mathematical. Hotel STPs collapse because kitchen COD is underestimated. Banquet multiplier is ignored. Oil impact on oxygen transfer is completely misunderstood. Equalization capacity is always insufficient in most hotels. Then what happens? Foam appears, sludge floats, clarifier collects solids. Complaints are raised, complaint call begins, and suddenly your STP fails. No, it is performing exactly as per design, not as per what is actual. Here is the uncomfortable truth. When we underestimate electrical load, the consultant hears about it immediately. When we underestimate organic load, failure takes time. That delay creates comfort, and comfort creates denial. By the time performance issue appears, the blame has shifted to the operator, to the vendor, to the operation and maintenance team. Optimism at design stage becomes crisis at operation stage. But the failure was not operational. It was biochemical under design. Different COD load means different load multiplier, different oil concentration, also a different biological stress on sewage treatment. This is Bioengineering 101. Reactor design must follow organic loading, not templates. If sewage strength changes, reactor design must also change. Otherwise, it's not bioengineering. It is, as I told, biological wishful thinking. And biology does not reward wishful thinking. MEP consultants, we pride ourselves on precision. Precision should not stop at HVAC. Precision should not stop at electrical. Precision must also reach the kitchen. A banquet hotel cannot be designed using domestic COD assumptions. Good bioengineering protects biological performance. Optimism protects drawings. Only one of those survives operation. In the future, you will also hear from us on how to design hotel STPs based on real CODs, how to calculate organic load in kilograms per day, how to account for banquet shock loads, how to size aeration and equalization properly, because STP design is not plumbing, it is biochemical engineering. Thank you.